Hey everybody, it's Armin. Today I got another build audit that I'm going over. This customer brought their car in, got 2.5 swapped at another shop that I guess bid lower than we did. So he went to that shop. He said he was very dissatisfied with his service. He's a local guy to me, so he brought it out to me and asked me if I'd go over it and see if I could figure out what's going on. So I have his initial concerns written here, and we're gonna see if we can't figure out if they're valid or what's going on here. So I've got the oil pressure gauge doesn't work. He heard bolts falling off the car when he picked it up. So I guess we're gonna look and see if there are bolts missing. The AC stopped working shortly after pickup. There is a major oil leak, which I can absolutely verify. It left a puddle over here. The car was actually parked right here. There's a sizable puddle right there from just the last day. There's a bunch of belt noise, like it makes a constant kind of a chattery, squeaky noise, and he says the belt was interfering on the front cover pretty heavily. He did admit he tried to already clean that up to try and avoid interference, but he said he still needs to cut more. He wasn't sure how much to cut, but you can definitely see the damage on the belt when I took a peek. Let's see, the next thing is he says the car runs poorly. Well, he got the car initially and he said it runs poorly, and then he went to a local guy to have it retuned. I'm not gonna lie, it still runs kind of poorly, but there were two check engine lights that he initially had that I need to look into, and one was for there's a catalyst code, and then there's an intake tuning valve code. The intake tuning valve code, I'm gonna go and throw it out. I already know it has an aftermarket intake manifold, so that code should just be disabled, but the tuner should have disabled that already. The catalyst code, well, we got a couple of things we can look at to see if that's a valid one or not. Let's see. I think that about covered. Oh, there was one more thing. On pickup, he had a broken dipstick. As a background, this customer did buy our complete swap kit off of our website. Cams, valve springs, all the conversion components, seals, etc. He bought all that stuff from us, and he asked for all that to be installed. So we're also going to verify that all that was used. And one of those things was the dipstick, which he got his car back with a broken dipstick, which I think is, personally to me, that's kind of insulting. It came to us with a broken dipstick as well, and we just threw another one in for him because, well, that's the right thing to do. You shouldn't give a customer car back with a broken dipstick. That's silly. So I'm going to get this thing into a position where we can start looking at it, and you can go with me and see what we find. So I've got the car down, hood open. Before we go looking at anything, I just want to state that I will be looking over things from my point of view, so anything that I would have done different I will commentate on. So some of it you may call nitpicky, some of it may be just someone did a poor job, but I'm going to be calling out everything I see. No, I don't know necessarily if all of the things I call out are going to be the fault of the shop, maybe the customer, someone else did the work, I don't know. But the customer has asked me to audit the build, so as far as my end goes, I'm looking for anything that is different than how I would do it. That being said, let's go ahead and take a look. Okay, so we're looking under the hood. This customer has a battery relocation. He did state that he did the battery relocation himself, and there has been an electrical problem since then, which was before the swap. This ground right here is sitting on top of paint, so I'm sure it's getting minimal grounding. So that would definitely be a part to start at. That would need to be cleaned off to where it has good continuity. And usually we would hit it with something like a dielectric grease to avoid any problems. On top you'll see we do have our new dipstick. That's from us. Now, I don't know what's going on here. This is the PCB line running over to here, and it just sort of dumps into the wheel well. No catch can, no nothing, just dumping into the wheel well. I definitely would not be doing that. Let's see. The exhaust studs looks like they haven't been cut. That's a nitpicky one there because in all my instruction videos I say if you don't cut those, you're never getting this header out with the engine in. So good luck if anyone has to remove that in the future. Let's see. Down here, the belt appears to be coming off. Now I'm not entirely sure why. I need to look into it, but the belt is also kind of shredded, it's damaged. You can see the damage on the face. He had mentioned that this boss needed to be cut down more. You can already see it was touching. It's not touching right now. And then down in here, he said it was touching, and they managed to cut that. That looks like it's adequately clearanced. But something else must be going on here, because this looks like something's out of alignment here, but I'm not sure what could be out of alignment per se. You'll also notice there's definitely a ton of oil down there. It looks like oil's leaking from around this pulley, which is fairly common on these, but usually after some time, not right after you do a swap. And then down here, you can definitely see oil behind the crank pulley. That's usually indicative of a crank seal failure, so we'll take a look into that a little bit closer. So let's take a look over here. Is there anything going on? Let's see if I can get the camera down in here. Do you see that hose that the light is on? That is the PCV hose. It is kinked. It looks like it's kinked hard enough to where there's probably zero flow. So that PCV does nothing. The customer did mention that the EGR port was left wide open, and I told them that we would do the same. As long as the EGR valve is disconnected or disabled, that's not a problem. So that's kind of it for under the hood. Truth be told, yeah, I already did take a look under here before I started recording. I wanted to make sure that I wasn't just wasting time on camera looking for stuff. So let's see, there's nothing else going on under here. Oh, I forgot a big one. I had looked at the crank pulley. The crank pulley, you know what, I'm gonna rotate it over. The crank pulley has markings on it as if it was being torqued, but it, because if you know, the torque spec on these is supposed to be all the way to 90 degrees after you hit your 74 foot-pounds. The thing is, I'll show you. So if you look here, we'll assume that's the starting spot, right? 90 degrees is here. This bolt was tightened maybe 60 degrees. So that means the crank bolt wasn't even torqued all the way, which sucks. After seeing the crank bolt not being tightened, that makes me want to check all the timing, because that's scary. If someone's not capable of torquing the crank bolt appropriately, then I doubt their ability to do the whole timing service. So it looks like I'm going to be pulling off the valve cover, verifying that the timing was done right. While we're in there, hey, we can go ahead and measure valve lash, and we should be able to verify if they did install the valve springs that were supplied. Next thing, we're going to lift this thing up, take a look at the underside. So one of the first things I noticed, is kind of goofy first thing to notice, is this nut right here, that guy, that is an end link nut. Meanwhile, the nut that's supposed to go there is on the end link. I don't know if these got mixed up in the swap process or not, but the reason that you put the lock nut on the end link is because end links like to back out. The nuts on end links like to back out, so you'll see there's a lock nut here, and that flange nut matches the flange nut up there. Again, this is a nitpicky thing, but I'd say the correct bolt and the correct nut go where they came from. This side, perfectly fine. Nothing wrong here. The under tray is falling apart. There's supposed to be a bolt here, a bolt there, and a clip here and a clip there. So this sucks because this doesn't block the airflow from going under the radiator. You know, that foam piece is supposed to be pushed up to where it forces air up into the radiator and condenser. So it sort of mitigates your cooling effect when it's not secured. This is a goofy one I noticed. That bottom stud that you're supposed to remove off of the 2.5 engine, this guy right here, it's still there. So now, the customer had asked me to replace the compressor on this thing because the compressor, he thinks the compressor's bad. I hope I can get that stud out, because otherwise there's no way to get this compressor out easily except for, well, cutting some stuff. Anyway, that's just sort of sloppy on in my opinion, because those are supposed to be removed and you should be installing it using the OEM bolts. Over here, so there was a mention about the oil pressure gauge not working. You'll notice that The connector's green because the OEM sensor is green. But hey, that doesn't look green, does it? That looks gray. It was never swapped over. So we know exactly why his oil pressure gauge doesn't work. Given, I'm not saying it's real. They're a dummy gauge from the factory, but in my instructions I specify that you're supposed to swap it over for it to work. This is sort of on the nose. That's an O2 socket. It's just sitting there, still attached. Good job, you're not getting your tool back. Catalyst code? Well, there's your answer. Both O2 sensors are in the exact same position. No downstream O2 sensor is behind the catalyst. So what we're gonna have to do is drop the mid pipe, weld a bung on it, get an extension, and bring that sensor back here. And considering we are in an emissions county, this kind of sucks for the customer because he has to pass emissions and he was given a car that's not ready for passing emissions. This is maybe nitpicky. These are bolts. These are supposed to be studs with springs and nuts from the factory. So we'll be swapping those out for OEMs as appropriate. It is a flexible joint from the factory. With bolts, it's not a flexible joint anymore. Another nitpick. See the bolt on the bottom left of the alternator looks different than the one on the bottom right. The one on the bottom right, funny enough, is actually a front cover bolt from these Duratec motors. So there were extra bolts laying around and someone just threw one in that fit. I'm not saying it doesn't fit, but the appropriate bolt's supposed to go there, not a random one. Now down here, another nitpicky thing. If the heat shielding's falling apart, we absolutely always recommend replacing it because, well, it's falling apart. That should be replaced. We keep them on shelf right there. That's probably something that we bid him as well. And then one of the last things I noticed under here was the power plant frame is not in alignment. You can see the witness marks on the side of the nuts don't line up with them. All right, sorry, I paused there to go put some gloves on so I could feel around and make sure we have all of our transmission tunnel bolts, or all of our transmission bolts. So I got in here and I checked. All of them are there. They're at least tight enough to where my finger can't break them loose, but we are missing one. It's the one that's right here. There is no bolt right here, so that one is missing. I don't know of any other bolts that are missing on this thing. I gave it a pretty solid look over from front to rear and I saw nothing missing. So we'll just go ahead and sit down, write some notes, come up with a plan of action moving forward, and go from there. Oh, let's go ahead and bring the car down and run it so you can hear how it runs and what the sounds are that it's making. So you'll notice there's a squeaky noise happening. We need to figure out what that squeaky noise is, because it's not supposed to be doing that. And it sounds like it's running a little rough. I mean, we expect cam cars to run a little bit rough, but this sounds a little too rough, if you follow me. Based on all of our other cars that we built, usually don't sound like this. But hey, he said it was running worse when he got it, so I don't know. So like I said, I'm gonna go sit down, I'm gonna write down notes, come up with a plan of action, and then we'll talk about what we're gonna do from here. All right, so moving right along, I've written down my findings. I have my original customer concerns up here. I have my findings here. This is just our standard work order stuff where I write down my notes. So plan of action as of the immediate is while it's on the lift, I'm gonna take it up, I'm gonna remove that O2 sensor wrench, I'm gonna swap out the pressure switch, I'm going to drop the mid pipe. We're going to weld a downstream O2 sensor bung. I do need to get an extension so I can hook that up. Then he'll be able to have no check engine light for that. And we'll see what else we can take care of on the underside. And then after that, I will move it over here into this position so I can dive into doing timing checking and all that stuff. But I try not to occupy my lifts for too long. I found a loose-ish bolt. There's a gap right there, as you can see. Weird thing is it's not loose, so I'm gonna pop that off of there and see if maybe it's tweaked or something. I'm not sure what to make of that. I just plugged the O2 sensor hole here. we're gonna have a little fun here a little bit. I'm gonna run my infrared laser on this, see if it cleans it up from all the rust. And that's gonna go into the mid-pipe after we get our downstream extension. All right, I'm attempting to remove the mid-pipe, and remember those two bolts that are in the header? Left one came out with some trouble. The right one is cross-threaded in there. So now it is spinning freely. Since my impact ultimately can break it loose, it's just it broke the threads first. So we're gonna cut it out of there now so I can figure out the next plan of action here. I managed to cut the head off of it, and I want to point out it's not actually straight in there, so it was definitely cross-threaded. So it went in at an angle, it looks like. You can see it hanging out a little that direction. Hopefully I can get that out of there without too much trouble, and then we're gonna put in the OEM studs. What I've started doing on those is because they like to pull out when you remove the nuts, is I've started just putting a little MIG bead along the bottom to make sure that the stud stays stuck into the header. So I managed to drill enough hole into it to put it into failure, and then I used a punch and I hammered it through. So we have the head of the bolt here, we have the part I cut off here, and then we have the part I punched through here, which you can see there are no threads left on this. It was sent into submission. I had Austin weld this up real quick just so I could keep on moving. We have our bung now welded onto the mid-pipe. So my next thing is I'm going to install the studs onto this header, and I'm going to, usually, like I said, I put a little bead around the base of it. This one I'm going to essentially have to just install it with welding because there's no more threads left. Okay, so I checked my shelf stock. I've got a ton of these guys. These are the OEM studs. This end goes into the header, this end sticks out. Let's see, I've got a bunch of OEM nuts, brand new and shiny. What I don't have new and shiny are springs, but I won't bill the customer for these, but I found these on shelf. I am out of these right now, so I'll just use those. Full transparency here, so you see what I'm doing. I'm gonna go ahead and attempt to thread in the left side one, and then we're gonna weld in the right side one. We've completed the welding. I realigned the power plant frame. It's lined up correctly now. So this one had no threads left, so we just glob welded it, like with the MIG welder. I'm not gonna say they're the prettiest welds, but you know, this is just functional stuff here. We're not a beautiful welding shop or anything, but these are never gonna be backed out now. So now we can put the mid-pipe on. We won't be able to hook up the O2 sensor yet because we're waiting on that extension to come in. We've ordered it today. I mean, it might take until next week, but at least we'll be able to put the O2 sensor in. And I guess next I'll go ahead and take care of switching out that oil pressure switch. Hold on a second. I just got one yesterday off of Mr. Santiago's car because he got the rotary tronics gauge, no longer needs this. So, this will be donated to this car. Got the mid-pipe back installed. You can see the brand new shiny nuts with the springs behind them. The O2 sensor dangling here, we're going to P-clip that. What we usually do is we run P-clips down the side here. That way it stays out of the way of the exhaust, won't get burnt up. That's, I think, all of it. Now we're gonna get that sensor out of there and replace it with the switch. Oh yeah, I also threw some bolts in here and 2 clips in here, so this is no longer hanging. Okay, last thing for today, I went ahead and installed that bolt right there, and I have replaced out the switch, so now the gauge on the dash should work. That concludes all the work for today, and under the car, at least for now, until, again, the O2 sensor extension comes in. So I'm gonna take this thing off the lift, stick it over there, and let's see how the timing is on this thing. All right, I've got the car moved over here. I'm gonna go ahead and hook up the AC machine, pull it empty. Customer says that it was charged from cans, so that tells me they have no idea how much refrigerant they put in. We're a professional shop. We have an actual AC machine. It pulls the system empty, lets you know how much there was, and then you can control how much goes back in down to the hundredth of a pound. So we're gonna put in the correct amount. But I wanna see just how much is in this thing. So we're gonna grab the AC machine, pull it empty. Okay, so yesterday we pulled the AC system empty just before I left. And let's pull this up on the menu, and you can see with me how much it pulled out. me say, last recovered quantity, it recovered 0.82. So that is less than what the system takes. It takes 1 pound. Personally, I actually always fill these with 1.1 pound, admittedly. I've worked on plenty of these to where I found that 1.1 actually gives you just better results without giving any drawback to like overcharge. But either way, it has 0.82 in it. It's supposed to have 1 pound. Before I go and just throw in a compressor into this thing, I want to make sure that we're doing the correct thing as well. So I got a bunch of other stuff to check. We'll come back to the AC after I check all the other stuff. Okay, I've got the front end up on jack stands. We're gonna go ahead and start tearing down just enough to be able to verify timing before I pull the crank pulley off so I can replace out that crank seal. Not really relevant to the video, but in my previous video I had said that I was coming out with a crank seal installer tool. Well, I think this one should be the final, so I guess we'll get to try it out today. Just a simple little tool that I was going to start throwing into my kits. I also have a BBT seal installer. I designed this one just because it makes it easier for the BBT seal on. That brings me to actually a next thing. I noticed that the BBT seal was installed upside down on this thing. I'm not saying it's leaking, but it's installed upside down. It's supposed to be with the ugly side up, if you will. Well, either way, yeah, let's go ahead and start taking things apart. So I'm looking for reasons of why the belt's crooked. My first thought was maybe the bolts on the alternator, because one was incorrect. I figured I'd check all of them. They're actually all front cover bolts. And you ask, how do I know that? Well, I know because they're flat heads like this. Some of them are open heads, but you will never see a closed head like this on an OEM alternator for an NC. But furthermore, that's RTV. See the RTV on it? This was definitely on a front cover. It's a little bit shorter than the OEM for the alternator, if I remember correctly. But go with me here. I loosened all 3 bolts. The alternator has a significant amount of play to it. So I'm gonna see if I have some OEM alternator bolts on hand to put in here and see if it has less play. So if it has less play after I put OEM bolts in, we may have our culprit as to why the belt is acting goofy. I don't see any reason as to why the tensioner is acting, the idler would be at fault, because it has the spacer and that's kind of it. It was tightened all the way down. All right, I managed to find 2 OEM alternator bolts. I don't have 3, but I'll see if I can't get him another one. But let me demonstrate the difference here. So you can definitely see the head of this has a significant amount of flange because it's a 13. This one is a 14. That's what the OEM one is. But also, the front cover bolts, let me see. Front cover bolts have a neck right here where it necks down. That means this is skinny. This doesn't neck down. It's the same size the whole way. let's install 2 of these and see if the alternator has less play to it. Okay, so it does look like the bolts made a difference. The play in the alternator is near none now. So, incorrect bolts on the alternator. I'm gonna make sure I get him a 3rd one so we have all 3 correct bolts on the alternator. Next step, let's go ahead and get the valve cover off. So we'll be taking off hood, cowl, assembly, etc., and then getting that valve cover off so we can start looking at timing. curious detail. The shop signed the ECU with the mileage I guess the car was swapped at, but that's not why I want to show this. It's because the little breather thing on top that protects this thing from water ingress is broken. So if it protects from water ingress, that means water can get into this. And if water gets into this, the ECU is toast. That's not okay. We'll need to figure out something to put over it. All right, another nitpicky detail. These are bolts that you use to tie down the battery. They're like, I don't know, what, 15 millimeters long? There are like 20 millimeter long ones that you use for holding in the power steering tank. These hold on by like 2 threads. So these were holding down the power steering tank. And then a moment ago when I was moving the ECU, there is a long bolt that they used to ground off the ECU, that little plate on top. It's supposed to be a really short one so it doesn't interfere with the thing below it. It wasn't long enough to interfere with the part below it or damage it, but that also left the too short of a bolt as the ground bolt. Again, just nitpicky, but I'm gonna make sure they go back in their correct spot. Found another case of potential misalignment on the power steering pump. All 3 of the bolts in the power steering are this, which is all thread. I just, as you saw, I just pulled one off of Mr. Santiago's car there. You'll notice this one is not all thread, and there is a raised shoulder to it. The raised shoulder aligns the power steering pump. So now I need to go dig and see if I can find 3 more of these, since all 3 on the power steering pump here are all thread. And the moment I loosened all 3 of them, the power steering pump was just loose as heck. So, yeah, we're gonna go do some digging. I took some digging, but I found 3 matching bolts. I put Mr. Santiago's bolt back into his car, so now I'm gonna put these on. And again, they have the shoulder. The length was correct on those ones that I pulled off, but the shoulder is the problem. While I have the power steering pump down and out of the way, I'm gonna take care of that kinked PCV line. Go ahead and cut it shorter and then reinstall it to where it is not kinked. Personally, if the customer plans on doing any sort of racing or anything, I would absolutely recommend a catch can for these setups, and you just run it off of that side of the block, up and around, then run this one concurrently into a catch can and vent to atmosphere. It would require a retune, but it sounds like we're already going to need a retune in this thing anyway. Okay, I'm going to take care of the stuff under the intake manifold. All right, you just saw me cut about 4 inches off of that PCV hose. Let's take a look at it. Look at that, it's not kinked. All it took was a couple of extra seconds of my time. Here we go. Also, weird, what the heck is all that mess under there? It looks like there's a bunch of RTV on that coolant hose. All right, you just saw me beat the crap out of that pipe with a hammer. The reason is that pipe normally points a little bit forwards, and it was pushed up against the manifold. Without a doubt, after probably a year, that would have chafed through. I've seen it happen. Not necessarily on this manifold, but I've seen it happen on other aftermarket manifolds. Pretty much all of them you have to do that, so that's definitely something I would have done. And hey, I just did it too. So now there's no worry about interference there. Now I can remove it. Also, all the AC O-rings that I saw thus far, they have all original, so that's something I do. Whenever I do these motor swaps, I take the AC system apart, I replace all the O-rings. We're in here, you're paying good money for the work, you know, why not take care of it? Just sort of a while you're in there thing. Just pulled the valve cover off. No RTV on the corners. I mean, it wasn't leaking, but also that's standard. You're supposed to do that. You're supposed to put RTV right there and right there. Or not, I guess. All right, sloppy workmanship, dude. Sloppy. Seriously? It's a 19. You just remove it. So they just broke the head off of it and left it. That's the OEM Ford head temp sensor. They just broke it off and left it. That's, what the hell? Okay, the time's come to check the timing. We're gonna see how well they did. Got my timing bar here for the cams. What we're gonna do first is we're gonna rotate it until this fits in. Hopefully it slots in both of them without too much difficulty. That means the cams are at least in sync with each other. Then, we're gonna send this into the side of the block, and I should feel it tap right up against the crankshaft. And then what we can do to further test is we remove the cam bar and try to rotate the crank. And if the crank doesn't move, then cool, the crank is in time. After that, then we test, we're gonna get down there with a mirror. We're gonna see if the crank pulley is installed straight, as well as if the trigger, the pickup is, the crank sensor is in the correct position also. All right, let's do it. All right, we slotted into both the cams at the same time. Those are good. All right, the tool bottomed out. I'm gonna remove the cam holding bar, and then we're gonna try to rotate. I didn't like that, it just moved. I don't know how many degrees that was, but I would give it at least 5. It could be 5 or 10. Let's go ahead and get down there with a mirror and see if the crank is in the right position next. If we get the camera down in here, you'll see. Let's see if I can get the camera to see it. Hold on, gotta get my light in position. Okay, so if we get in here, it's gonna be difficult to see. Jesus. Hold on. There we go. That's going to be a little easier to see. All right. So now, look at this right here, and you'll see it is a little bit past. The trigger position is a little bit past where it needs to be. And then when you look down here, the hole, it's a little hard to see, but the hole is also just a touch off of where it's supposed to be. Which, I mean, it seems like that's the amount that it moved whenever I was rotating it. So either way, I have to retime it either way because, well, the crank bolt has to come off in order for us to do the front main seal, and the front main seal is leaking. So I'm going to be checking the lash now. We're going to go with OEM spec combined with Esslinger spec just to be generous. So that means 06 to 08 for the intake, plus 08 to 10 for the intake. So 06 to 10 for the intake, and then 08 to 12 for the exhaust. So let's see how we do. We're off to a bad start. All right, I need some paper because it looks like I'm gonna have to write all this down. Okay, to make things go a little easier, I'm gonna have my wife write the stuff down while I call it out. Just make things a little smoother. I'm not trying to do everything at once. Okay, this is going to be a problem on that, let's see, on the fourth valve. I don't have a feeler gauge small enough to go into the slot. And my smallest one is .0015, so we're going to have to open that one up a lot. Okay, I got numbers for us. Let's go over them. We have, on the exhaust side, we have 13, 16, 17, 15, 14, 16, 14, 14. So we're gonna need to lash all those for sure, because they need to be, well, 10, right? Let's go here. We have intake, 12, 12, 13. I went ahead and just put a 0 there because, well, can't measure any smaller than .0015, so 0. 11, 12, 12, 9. So hey, like, one of these kind of passes at 9. Okay, so I guess now I'm gonna take a small break. But next step is gonna be taking the timing apart, and then we're gonna do buckets. Gotta figure out what buckets they are first, and then we can make a calculation. While we have it apart, we're gonna take care of cleaning up the front cover. We're gonna reseal it, of course. We will be doing an oil change. And then, let's see what else. We'll also make sure that it has the valve springs that he paid for. He bought valve springs from us, he supplied them to be installed, and we'll make sure they're in there when we pull the buckets. Guys, it is really frustrating taking this thing apart because a friction washer on the backside of the bolt. This is cluelessness. Now I wonder, do we have friction washers on the cams? Like, dude, a friction washer behind the head of the bolt? Not to mention the bolt's covered in oil. Like, this is asinine. And it looks like we also have a friction washer behind the crank Now I want to know, is this one that has serrated teeth or not? Because if it's serrated, then this is a big no-no. It does not look to be a serrated crank gear. There's some interesting markings on it, but we'll pull it out and we'll see. Because obviously I got to pull all the timing out. So now we're just gonna take the front cover off and then take the cams out. Proceed. Second bolt I pull off of the front cover is the long one. It's not in the long position, it was in the top left. Also, I'd like to point out, so the big 13s that are up in the top center, one was not even tight. No effort, came right off. The other two were tightened. One of these was tight, the other one wasn't. This is a real shame. This is actually a real shame. So this is the front cover. In order to do these swaps, you have to remove the crank pulley and transfer it over, which means you have to take the crank pulley off of the 2.5, right? That is the original gasket, the original crank seal. We supplied this customer with that in our kit. It's not replaced because they're not black. So it's just very disappointing. I'll show. I have an OEM one here, and you'll see it's kind of a brownish color. So very obviously this was not replaced at all. And you can just see oil everywhere. It's a real shame that a shop would do this. This is pathetic work. Like I'm actually frustrated now because this customer paid money to have things done, and I'm having to fix it because someone else couldn't do a good job. I'm not mad that the customer went to somewhere for cheaper. I'm mad that he has to pay them and then pay me. That really brings the community down. This is pathetic work. Oh wow, and let's look at the back. The back, check this out. It doesn't look like RTV was ever cleaned off. It looks like more was just caked on. Look how much RTV is in here. You can even see where it wasn't tightened down because it's covering a lot of these sections with how it's flattened. This wasn't even cleaned off before it was RTV'd. All right, well, we got to this part. I didn't find any more front bolts that were in the wrong spot because you literally can't. The 2 bolts that needed to go in a specific spot weren't in those spots, or rather the 1 bolt. That 1 bolt that was supposed to go in a specific spot wasn't in its spot. All right. I don't see any markings on the cam bolts, but that doesn't mean they weren't torqued to yield appropriately. I mean, reasonably, I could try to break them loose and see if they break loose at higher than 60, higher than 30, which they should. I mean, the car wouldn't run if it was just torqued to 30. But you see, when I do these now, I don't mark them anymore on the cam bolts because my torque wrench does degrees. So I'm able to do that. But I also do it on camera, so you can always go back and check my work. Kind of like I'm going to do these on camera. You'll be able to see that I do them with my digital torque wrench. Guys, it gets worse. You saw I pulled a washer already off of the crank nose behind the pulley. Another one. 3 crank washers, and I don't even have the gear off yet. It gets even better. It's a serrated tooth crank gear. I'm gonna just go ahead and take a break here. I'm just mad. This is insulting. This is insulting to all shops that try to do good work. This is absolutely insulting. And I'm sorry to all of you who see this. So it would appear that the cam bolts were not very tight. It took very little effort to get them off. I'm not going to guess at the torque value on them though, but what I will tell you is this car is really pissing me off because the person who built this is a fucking idiot. The friction washers are behind the bolts. Get out of our fucking industry. You are a disgrace. I just want to take a pause. This really pisses me off. If you've seen a bunch of my videos, I'm not emotional about this. It's like, hey, you know, I'm disappointed. No, this pisses me off. This brings the industry down. People are expecting to pay for good quality work, and I don't give a shit if you paid $200 or even free. This is disrespectful work. You shouldn't even accept the work if this is the quality you're gonna do. The bolts on the guide for the chain are also loose. Congratulations, you can't even tighten a bolt. Just to show what I'm talking about, this is a serrated gear. It does not require friction washers. I pulled 3 friction washers off. You're only even supposed to have 2 if you had a friction surface type one. One bolt was never tightened on the cam caps. Fortunately, only one. Okay, we're nearing the end of what I can tear down reasonably before it becomes a lot more invasive. The last thing we're verifying is that he has the valve springs that he supplied. That's it. That's it. There's no valve springs in this thing. This was never upgraded. So the customer supplied all this hoping it would be done, and it wasn't done. So once again, shame on you. You break the trust between the consumer and the shop, and you give shops like us a bad name. This hurts the industry. So now we're gonna have to install valve springs. So at this point, we're actually coming to a screeching halt because I am fresh out of valve springs. I had to install a set. No, I think we just sold out of them. Well, either way, I don't have any. This is still all very shameful because, of course, now I have to wait for valve springs so I can do what another shop should have done. Fucking disgrace. Okay, so I'm gonna take a break from the camera for just a little bit. I'm gonna play cleanup. This is a bunch of stuff that I don't have to record. I don't really need to record. I'm going to clean up the front cover of both layers of RTV. I'm going to replace the crank seal with a brand new one. I will show you that I install a brand new one. I'm going to clean up the front of the engine from both layers of RTV. I will go ahead and do my calculation on the buckets so that way I can be prepared for after we do the valve springs, but the valve springs won't be here today, so that's not something I'm going to be reinstalling today. But this is pretty much the extent of the teardown. Now it's just clean up, reassemble, and wait on that downstream O2 sensor extension. I threw the other front cover out because after I cleaned it, the paint was just falling off all over the face of it, and I was like, that's uglier than just a regular front cover. So I pitched that one, just got one extra one off of the shelf. It's already been clearance cut. I just clearance cut it. I cleaned the whole face, as you see. There's no RTV left anywhere. Now we're going to put in a new front main seal, and I'm going to do it on camera so you can see what it looks like to install a front main seal. And today we're actually going to do it together with my new tool. New in package. That's what is included in my kits. It is kind of brownish. We're going to stick it on our tool here. My hammer. There's my hammer. I'm gonna have a sit down. And that's it. Yeah, that was it. Cool. Front main seal installed perfectly. Flat. Awesome. Yeah, I'll start throwing these in my kits. So anyone who wants one, I'll throw it in whatever you order if you want. You just drop me a line. Okay, now I gotta do the really hard part. I gotta clean the front of the engine. So, not stuff I'm gonna do on camera. You guys have seen me do this stuff before. I got nothing to hide there. Just gonna take my time, make sure the front's cleaned up. Mazda's supposed to deliver me some valve springs today. Like I said, I was out yesterday. So, once those come in, that's kind of it. We're just gonna run through reassembly. Okay, Mazda just delivered. It's well after lunch, but I'm going to do everything I can to get this together today. So maybe we can fire it up tomorrow morning or something. I'll come in on the weekend, make sure this thing is done. We have our valve springs. Notice they have a white stripe at the top, like the top 3 coils are white. That is our indicator that they are the Mazda Speed valve springs. The OEM ones just have a stripe like down the spring. So I'm gonna go ahead and get these guys unpackaged, assembled with the keepers and stuff, and then I'm gonna turn Seth loose to install all of them. Okay, I'm about to turn this over to Seth. We've got the leak down tester installed, so that means cylinder 1 is at BDC. We've got our Company 23 tool here. We've got all of our Mazda Speed valve springs here. You can tell, again, because they are white at the top. And I've already assembled all the keepers and stuff, so he'll be able to just drop them all in. Again, this is just standard work. This isn't really, I guess, pertinent to the video as much, so I'm just gonna let him do it off camera. Completed the installation of valve springs. You can tell because, once again, white on the top. So all those have been changed out. We are now at BDC because of the leak down tester, so I will need to rotate this over a little bit to get us away from a TDC, any of the TDCs, because of course we're on TDC on 2 and 3 now. And I'm gonna be putting cams in and spinning them over. I've gathered up all my buckets already per my spreadsheet and my calculation. They're set over there. We're gonna put them in and lash this correctly. I spoke to the customer and the tuner yesterday and today, and this car reportedly had a cylinder 2 misfire that they had coming up. And what do you know, cylinder 2 is the one that had a 0 lash. So I wonder if that's related. Stuck open valve, no compression, right? Or low compression. Okay, so yeah, we're gonna go ahead and commence with doing the cam stuff. Okay, we've gone with our next round of measurements. I got much better numbers. I got, on the exhaust side, we got 8 to 10 thou. On the intake side, I've got as low as 3 and as high as 8. So we will be relashing both sides just because, again, I like to be as close to spec as possible. However, I'd like to point out, when we first measured, I couldn't get a measurement on bucket number 4 on the intake side. That's the cylinder 2 that was, I guess, stuck open. We actually know now how stuck open it was. I assumed 0 wasn't enough. So 0 would have been 6 thou off. But apparently we're still, after putting in a much different bucket, we're still 3 thou. So that's another 3 thou off. So we were a total of 9 thou off. That's pretty significant. So the valve was stuck open by at least 3 thou if you consider 0 to be not open, which in most cases with cams that may stick open depending on a couple of factors. There's a reason we have lash values though. So I'm gonna go hit the calculator again, and then we're gonna regather with buckets and then do it again. Calculation completed. I got the buckets off the shelf. Now I need to take this apart, reorganize buckets, install, check again. Looks like we're almost there. I got really close this time. That one that was essentially stuck open, I managed to get it okay. We had, initially it came in with a 322 bucket. We ended up with a 100 bucket in order to get it to spec. So that's how far off we were. That's 3.2 thou? No, that's 0.32 millimeter. I think that's what it is. Either way. So I'm just gonna change this one here. I put a 402 in there, but it didn't open the gap up enough. So I'm gonna move that one down so I can get that one. The rest of them, perfectly fine. And then we're gonna get to timing it. You know what the problem was? I put a 462 back in there. That's why. All right, move some stuff around. I'm gonna go ahead and take care of getting the tensioner ready for the chain. Then I'm gonna have to rotate this thing over to TDC now. I do have my crank bolt installed, and what I usually do is for these in-car ones, what I'm gonna do is I'm gonna rotate it a little past TDC. That way when I hit it with my electric right angle ratchet, it'll pop that bolt loose, and if it does move a little bit, it's still past TDC. And then when I feed that alignment tool in, it'll push it into position, and then we're good. So I'd like to demonstrate. I called something out earlier. This is a friction washer. The friction washer goes behind the cam gear. Its job is to lock the cam gear to the cam, not create friction between the gear and the bolt. Because if you change the friction value between the bolt and the gear, then you're gonna decrease the amount of torque, or you're gonna decrease the clamping force for the equivalent amount of torque. So we're gonna put that on the back here. We're gonna do the same on the intake. Okay, this is the part where I torque the cams. We've already allowed the tension. We've unleashed the tensioner. The tensioner is now pulling tension. The bolts are tight on the tensioner. The bolts are tight on the guide, as they should be. And now we're going to torque the cams. So I'm going to set this guy. We're going to do our initial torque, and then we're going to do our yield. I apologize, it's sort of behind my back here. Okay, now we set this thing for our angle. It's set for 60 degrees. Let's go. Set. Now we move to installing the front cover. I'm gonna let it dry overnight, and tomorrow I'm gonna come in, put the crank pulley on, and reassemble everything else. I'm gonna give it one last wipe down to make sure the front is all clean. Same with the front cover. Put a nice bead of RTV on it, stick it on. You know, I'm gonna take just a second and get some of this RTV off these bolts because these bolts are caked up. Be right back. Okay, we come to the stopping point for the day. We got the front cover on, all the bolts are just cinched down, and then we're gonna let it just dry all night. I'm gonna come back in the morning, tighten everything, crank pulley on, valve cover on, run this thing, see if it sounds better. All right, it's Saturday morning. We're gonna go ahead and tighten up all the stuff on the front cover. We're gonna install the crank pulley. We're gonna verify our timing, and we're just gonna reassemble the car. And everything should run great after this. Possibly it'll require a retune now, of course, because the one cylinder is no longer, doesn't have a stuck valve anymore. All right, let's get to it. So I called something else out earlier, and I'd like to show how I knew what I was looking at. So what we have here is the crank bolt. I've already torqued it to its 74 foot-pounds, and we need to do a 90-degree yield on it. So I've marked the head on a vertex here, and then on a flat over here, I marked yellow. So now, assuming I can line those lines up, that is 90 degrees of yield, or 90 degrees of stretch, if you will. So we're going to be matching those lines up. And then I'll show that I lined them up. Because if you remember earlier in the video, I looked and it wasn't all the way. It was marked, but it wasn't pulled all the way to the 90 degrees. So to me, that's the flag that, hey, you didn't tighten it enough. So now let's tighten it enough. All right, for the pure transparency of it, I'll show you my markings. The yellow lines up with the yellow. We have torqued to 90 degrees. You also got to witness me do it. Now, we're going to proceed with rolling it over and getting it back to the TDC position of, well, the compression stroke, and then we'll verify that the timing's good. So we're getting close to the TDC position, so I'm going to go ahead and throw the pin in the side here. Okay, the pin is now bottomed out. Take a listen. Heard that? All right. So now we're going to verify the crank is at TDC. Well, we verified that the crankshaft itself is at TDC. Now with a mirror, I'm going to verify that my hole lines back up with the crank pulley and the front cover, and then I'm also going to slip in the timing holder for the cams so we know that all that's lined up too. Looks like we're okay there. All right, our timing is now verified. I'm gonna go ahead and install the, well, I guess I'm gonna change the plug out and then put in the crank holder tool. I'm gonna pull that out. I'm gonna go ahead and replace it with the plug that it needs to be. Then I'm going to put in the crank sensor and line it up appropriately with the tooth on the crank trigger wheel. Okay, just installed the belt, and I'd like to point out everything fits like it's supposed to. Look at that. Everything fits like it's supposed to. The belt is behind the face of the pulley, not hanging over it. The alternator's in its correct position. The power steering's in its correct position. Yes, I know. This bolt's still here. I need to remove that and then replace it out. But the other two bolts are tight. I wanted to make sure all that was good, so now we can move forward. All right, I got a little ahead of myself there. I put in the coil packs before I put the spark plugs in. But hey, I noticed, I went back and I put the spark plugs in. Earlier I'd mentioned that the wrong bolts were holding down the power steering tank. I found one correct one. I'm going to use another one that's about the same length, a little bit longer, because I want to make sure the thing is well anchored. It's kind of embarrassing. I like to do things with the correct OEM bolts, but I don't have any more of these. Because I mean, whenever we've used them on part out or taken them off of part out cars, those are really useful bolts because you know it's a flanged head on a stick. We use those a lot. Okay, that's all secured. You just saw me put dielectric grease on the ground. I'll put it on the positive as well. It's just a good practice. I zip tied the power line over here out of the way. Shoot, what am I doing? I'll show you. There you see it's greasy. It's greasy. And then I put a couple of zip ties here to hold this over here. Okay, we're actually at a point where we could start it, but I need to change the oil. So I'm gonna go ahead and take care of the oil change. I'm not gonna do it on camera because it's under the frickin' car. And then if the car runs great, then we'll go ahead and get it over to the lift so I can much more easily install that O2 sensor extension. Okay, I finished my oil change. I took the underplate out that goes under the oil pan. I took it outside, I pressure washed it. I've reassembled or reattached the sway bar. I also noticed a couple more bolts and clips missing from the under tray while I was under there. I've installed those. I gave a little bit of cleanup to where I could reach on the underside, but unfortunately, since the engine wasn't out, I couldn't exactly just pressure wash the subframe, because that would have been nice. So now we're going to go ahead and crank it over. I'm going to do oil pressure up first. I'm going to spin it over for a good 10 seconds to get the oil pressure up through the engine, and then we'll actually fire it up. Okay, so sorry, some customers came in. This sounds totally normal. Imagine that. There's no belt noise, there's no chatter, no misfire sound. It just sounds like a normal Cam 2.5 like they always do when I build them. Or like when you should be building them, that's how they should sound. The belt is now in the proper position. You can see it's not falling off of the idler. It's not making chattery, squeaky noises. It sounds perfectly normal. And I'm willing to bet now it doesn't have a misfire on cylinder 2. So let me go ahead and button everything up. I'll do all that stuff off camera and then we'll do a synopsis. All right, I've got a bunch of stuff reassembled, obviously. This is actually completely reassembled. And then the AC machine is running a cycle right now. I replaced out both of the valve cores, and I also replaced out 2 of the O-rings. Since 2 O-rings were exposed in the work I did, they both got replaced. I just finished doing the O2 sensor extension. Let's hop under the car so I can show you what we do for O2 sensors. So we put in an O2 sensor extension, and then from over here, we have a P-clip, another P-clip, a ton of zip ties, and this guy will now be able to pass emissions, or at least he won't set a CAT code. I can't speak for the rest of the stuff necessarily, but the CAT code should go away now. All right, we're gonna get this AC done. It's got another 15 minutes, and then I'll be able to see if the AC runs all right. So I have a verdict on the AC compressor here, and the AC compressor actually just doesn't engage at all. The system idles up, the fan turns on, and then the compressor doesn't spin. So it looks like we're going to be replacing the compressor out. We do have a unit this customer supplied, but that's not part of the scope of this video really. We're going to go ahead and end this portion of the video. Okay guys, we're done fixing the car. I appreciate you watching all of this footage. This has been a lot of footage, And unfortunately, it was a lot of footage just because there was so much to go over. This is a lot to take in. This is way worse than any other audit I'd ever done before. Any other car that I've even just inspected just casually or anything like this is far worse. The quality of workmanship is so bad, it's worse by a long shot than the worst employee I've ever fired for doing stupid or bad work. This is just incredible, unprecedented. I've heard of shops that do terrible work and just throw stuff together, but this actually just takes the cake. This customer brought a box of parts, again, our conversion kit, to the shop and said, please install all of these things. So that is a bond of trust there. You pay them money, you give them your car, you give them a box of parts. Now, industry standard would say, or even community standard would say, hey, if you're not going to use the parts, return them, or say you're not going to use them, right? Something along those lines. Customer got none of that stuff back, and the parts aren't on the car. That's a big breach of trust. That is a huge breach of trust. That's a breach of trust in the community too, the Miata community as well as the performance community, and then just automotive shops in general. It's a big breach because that brings down the trust. A lot of you are going to be watching this and go, how do I even trust a shop? Look, if you don't even trust me after watching this video, I totally understand. This is awful. How can you trust anybody after this? This is beyond bad workmanship. This is just cluelessness. So the thing is, the bond of trust also goes to the fact that, like, I have people who watch over my shoulder when I do my work. Sometimes they come and want to see what I'm doing. I've got no problem with that. I have nothing to hide. But do you know that, I mean, a lot of people don't even have a clue what I'm doing. So this is an egregious breach of trust because it's not reasonable to say this customer would go back and be able to check if the valve springs were installed or the lash was set right. You saw how much work it took for me to do it. And then to fix it, it's a significant amount of work. So that's a huge breach of trust. Now you don't even know what parts you're getting in your car. And by industry standards, this is beyond subpar. Most of you who work on your cars, you'll take the parts off the car, you'll go group them, you'll put them aside. If you're a little sloppy, hey, maybe you throw them together, but you make sure that it goes back together about right. Because even the worst workmanship, again, that I've seen, it still went back together and worked well. This didn't even work well. I am astounded that it made it to my shop. I'm astounded the timing didn't slip or any of that stuff. And what worries me the most is that the customer said when he dropped the car off, they told him they'd done over 80 of them by that time. So imagine this was someone's first time doing it, and this is still bad, but they've done over 80 of them up until this one, and they did this level of workmanship. It's egregious. Egregious. So all that being said, the customer just asked me to make this video documenting all the stuff, and it's up to him to complain about the shop and to do whatever he wants with this information. But I didn't say the name of the shop. It's up to you guys to, I guess, hear about it. But I know who did it, and you're probably watching this, and you know you did this work. And I hope you're ashamed of yourself for letting it out of your shop like this, because this video is now immortalizing how bad your work and ethics are. Abysmal work quality, abysmal work ethics. Please, get out of our industry. Get out of all industries. You are scum. Thank you to everyone else who watched this. I'm sorry to everyone who watched this and you know your cars were built by the same shop. And I'm sorry for everyone who now doesn't have trust for shops. And those who have trusted me, I appreciate it. I hope I nurture your trust, and I hope I can keep your trust. So, again, thank you for watching.